Okay, welcome back from break. This is our Unit 7 Day 1 notes, and we're going to start off with a really easy concept that I think you have already been told because we've talked about it this year, but I want to show you why it works. And the first one is the interior sum theorem. Interior, we know, means inside of something, and we're going to talk about triangles again. And it says, for triangles, the sum of the measures, so sum always means when we add things up. So when I add up the angles inside a triangle, they always equal 180. And we know that things that equal 180 make a straight line. This is 180 degrees. So I want to show you actually on a triangle how this works. So it's the same picture that we've got right here, but I'm going to show you on an actual triangle. And I just happened to cut this one out at random. This will work with any triangle you cut out. You can try this with. So if I take these three angles here, and I'm just going to mark them so that we can make sure we're looking at them. And I'm just going to put arrows and we're talking about those three triangles there. And then if I rip these triangles off, these angles, and I want you to see that I'm really doing it. If I put these three angles back together, they're going to make a straight line. Because the angles off of a triangle always add up to 180. And if you look at this, they made a straight line right there. That's literally what we're showing you here in this picture. If I tear off these three corners of the triangle and put them back together, they make 180 there. Because if I actually take the corners off of a triangle, they'll make a straight line. You can try this on your own. You can cut out any shape of triangle you want, and it's always going to work out. So, if I have a triangle like this, and I label the three corners X, Y, and Z, that's always going to be 180. So now, anytime we do a problem with this, we just say that these add up to 180. So if it gives me a picture like this, you can do it with or without a picture. What we're saying is if I have a triangle ABC, if A is 70 and B is 50, what is C? Well, they have to add up to 180. So I can do 50 plus 70 is 120, and then do 180 minus 120 gives me 60. So that angle right there is 60. I can do it over here, and I can do it another way, where I just take and subtract both of them from 180. So I do 180 minus 25 minus 131. It's the same thing we did here, except it's just a slightly different order on the calculator, and I would get, so I did this, and I get 24 for that other angle. In order to check these, just go back and put the three together and see if you equal 180. 24 plus 25 plus 131, 180, we got this right. Okay, our next theorem here talks about an exterior angle. Exterior angles are made when I take one of the sides and I extend it out as a straight line. So this part right here is my exterior angle. And what we're saying is if I take the exterior angle is equal to the sum of the measure of the remote interior angles. And this is the same triangle that you saw me rip apart earlier. I just took this one and I taped it back on into place. So what the exterior angle theorem says is that this exterior angle right here, if I make a straight line right here, this is the exterior angle right here. This is the exterior. And this exterior is equal to the sum of these two interior. So if I take this one and this one and put it over here, this one on the outside is equal to what I get when I add these two together. This one on the outside is always equal to this plus this. That's just how it works out every time. And it would work on any angle I chose out of this triangle. So that's what we have here. This exterior angle is equal to this one plus this one. So x plus y is equal to this exterior angle here. So on this problem, we can do it exactly that way. In order to find y, I just do 111 plus 34 is 145 degrees. And then in order to find x, well, these two make a straight line, so I can just subtract from 180. once I know this is 145, 180 minus 145 equals 35 degrees is x. Let's do it again on this problem. This time they didn't fill it in for us, so we have to fill it in on the triangle. X is 42, y is 38, and they want us to find these other two. So again, the exterior angle is just equal to the sum of these other two. So W equals 42 plus 38. So W is 80. And then to find Z, once I know this one's 80, these two make a straight line. So 180 minus 80 is 100 is Z. And our last and final formula for the day is talking about isosceles triangles. We know in an isosceles triangle that two sides are congruent. That's what makes it isosceles. And it's actually at least two sides are congruent. But what else is true is the base angles are also congruent. The base angles happen to be these two angles right here are called the base angles. So in this triangle ABC, if AB is equal to AC, then angle B, this one, and angle C, this one, are the base angles. Therefore, the measure of angle B is equal to the measure of angle C. So let's try that out, how that would work in a problem. So right here, I know these angles add up to how much? Same thing we had up there. They add up to 180. So I need to do 180 minus 40 is 140. And then this is an isosceles triangle, so I know this angle is the same as this angle, so they're both x. If they're both the same, I just need to take 140 and divide by 2, and I get each one of these is 70. If I want to check it, I can say 70 plus 40 is 180. Okay, here I have another isosceles triangle. I know this one is 75, so this one has to also equal 75. If I want to find this one at the top, I still do 180 minus 75 on my calculator, and I can get that the top angle is 30 degrees. Okay, now we're going to get some more complicated pictures here, and these are both isosceles triangles. You'll notice that those are all the same. I also know this angle right here is a right angle. So let's see what we can figure out. Well, if this is a right angle here, and this one is 28 degrees, this one I'm going to find by doing 90 minus 28. And I'm going to get that this one right here is 62 degrees. Well, if this is isosceles here, these two are equal. If this is 62, this is also 62. Then I can find this one by saying, well, these three in here add up to 180, so 180 minus 62 is 56 degrees is x. So you kind of have to start in one place, figure out what you might know, and then work around till you get to what you're looking for. Here we have two more isosceles triangles. This one is isosceles here, and look, the two base angles are 50 and 50. They're equal to each other. And then this top one is also isosceles. So I need to find first this one. Well, first if we look at this triangle here, I know 50 and 50, and I'm looking for this one. So 180 minus 50 tells us that y equals 80. Then I'm going to look at the top triangle where it says this top angle is 50, so 180 minus 50 is 130. But I know these two are equal to each other, so I do 130 divided by 2 is 65. And that's what x and z are. So 65 degrees is x, and 65 degrees is z.